Okay, so picture this. You're walking across the African savannah. It's like millions of years ago. It's hot. You're thirsty, and all of a sudden, bam, you see it. This like juicy carcass just sitting there, like
Mm,
perfect dinner, right?
yeah.
But here's the thing. You're a Kenyanthropus platyops,
Mm-mm.
one of our, early human ancestors. And your teeth, well, let's just say they aren't exactly made for tearing through hide and flesh. So what do you do?
Well, that is a question that has really just fascinated, paleoanthropologists for, yeah, I mean, decades now. And thanks to some really incredible recent discoveries, we might finally actually have an answer that like completely changes how we understand like early human ingenuity.
And this is where things get really, really exciting. We're talking about the oldest tools like ever found. These things date back 3.3 million years.
Yeah.
I think about that. That's older than the pyramids, older than Stonehenge. It's crazy. And well, we're going to be like diving deep into an interview with Professor Fred Spoor. He's like, an expert on these ancient tool makers. And trust me, what he has to say will make you rethink everything you thought you knew about like our early ancestors.
What's really, really remarkable about this discovery is that it pushes the whole timeline for tool making back by like almost a million years. Before this, the oldest tools we knew of were the Oldowan tools. Those are from around 2.6 million years ago.
So we're talking about a huge leap backwards in time. And it kind of makes you wonder who made these tools. What do they even look like? What could they even do?
Well, the prime suspect is the Kenyanthropus platyops you were talking about earlier. Now, try to picture this. A creature with like a surprisingly flat face, kind of a unique combination of primitive and more evolved features. These guys were walking around Kenya near Lake Turkana over 3 million years ago.
Kenyanthropus platyops.
Yeah.
It's a mouthful, isn't it? I'm picturing them trying to explain that name at like a party. But all jokes aside, how do we even know they were the ones making the tools?
It's almost like a detective story. Scientists found these kind of crude stone tools at a site called Lemekwi. It's in Kenya. And nearby, fossils of, you guessed it, Kenyanthropus platyops. So, that suggests a pretty strong link. Like, they were at the scene of the crime.
So they were there, but like, did they have the brains for it? Tool making seems pretty complicated.
And that's what makes this discovery so significant. Creating even these simple tools requires a level of cognitive ability that we didn't think existed so early in human evolution.
Hold on. So we're talking more than just like picking up a sharp rock and using it. Like, yeah, these early humans were actually thinking ahead, planning out how to like shape the stone to make it useful.
Exactly. They had to, select the right kind of stone, understand its properties, and then strike it in just the right way to make a sharp edge. I mean, that involves understanding cause and effect, being able to kind of visualize what they wanted to make and the dexterity to actually do it.
Wow, that's amazing. Yeah. So I think Professor Spoor mentioned there was some like pushback from other scientists when they presented their findings. Why was that?
Well, anytime you have a discovery that kind of challenges the established narrative, there's going to be some resistance, right? Some scientists weren't sure about accepting Kenyanthropus platyops as a distinct species, let alone giving them credit for such, advanced capabilities.
So, I mean, there were doubts about if they were even a separate species A and D, if they were smart enough to make tools. Sounds like Professor Spoor and his team had their work cut out for them.
Oh, they definitely did. But, that's how science works. Constantly questioning, testing, reevaluating. New discoveries often make us rethink what we thought we knew. And in this case, the evidence was strong enough to convince a lot of scientists.
Okay, so we've got these super old tools. We've got this, this interesting flat-faced ancestor, and we've got a whole scientific community that's been, well, kind of shaken up. So where do we go from here?
Well, to really get how revolutionary the Lemekwian tools are, we need to take a step back. We need to look at the bigger picture of tool cultures. Think of it like a timeline, The Lemekwian tools, that's the first chapter. Then you have the Old Dawn, and then the Acheulean tools. They get more and more sophisticated over time.
So if the Lemekwian tools are chapter 1, what can they tell us about the rest of the story? What comes next in this whole human evolution adventure?
That's a great question. The Lemekwian tools, they're simple, but they show a huge leap, in cognitive ability. It's like they suggest, planning, problem solving, maybe even some like social learning going on. And that really sets the stage for the more advanced tools that came later.
So it wasn't just like a one-time thing. Like some early human just got lucky, bashed a couple rocks together, and made something useful. This is the start of like a long process. It's a journey of innovation where each generation builds on what came before.
Exactly. And you can see that progression, when you look at the Oldowan tools. They show up about 700,000 years after the Lemequian tools, and you can see they're more refined. Like there's evidence of intentional flaking to get sharper edges and more versatile shapes. And then, even later you have the Acheulean tools. Those emerged around 1.7 million years ago, and they're even more advanced with like hand axes and cleavers. It shows they really mastered some pretty complex stone knapping techniques.
Okay, so we've got this progression, but I'm still kind of hung up on the whole social learning thing. How do we know they were actually like teaching each other how to make these tools? Were they having little classes, you know, around a campfire, showing each other the best way to hit a rock or something?
Well, we can't say for sure if they had like formal classes or anything, but the complexity, and the consistency of the tools does suggest some form of knowledge transfer was happening. It's pretty unlikely that each one just figured it out on their own. It makes more sense to think that they were watching each other, copying each other, and passing those skills down through the generations.
Yeah, that makes sense. Like if you saw your neighbor cracking open nuts with a rock, you'd probably pay attention. Maybe even try it yourself.
Exactly. And over time, those techniques would get better, they'd be shared, they'd be passed down. And that's how we see the development of more and more sophisticated tools.
So it's not just about the physical tools themselves, but about the social structures and the cognitive abilities that allowed for that innovation. It really paints a picture of our ancestors, not as like these lone preachers just trying to survive, but as groups working together, learning from each other and shaping their environment.
And that brings us to another interesting piece of this puzzle. We have these cut marks on animal bones. They were found at a site called Dikika in Ethiopia. And get this, they're even older than the Lemequian tools. They date back 3.4 million years.
Wait, so we might have evidence of tools being used even earlier than the Lemequian tools. How does that fit in with what we've been talking about?
It's a very interesting finding. I mean, there's still debate about whether the marks were made on purpose or just by accident. But the fact that they're there does suggest that our ancestors might have been, interacting with animal carcasses and maybe using tools even earlier than we thought.
So is this like a different species? I mean, Kenyanthropus platypus was around 3.3 million years ago. So who was making these marks at Dikika 3.4 million years ago?
That is the million-dollar question. It's possible there was another hominin species that we haven't discovered yet that was responsible for these marks. And we have to remember we're only working with, a very incomplete fossil record. There could be whole groups of early humans that we just haven't found yet.
Okay, so we've got Kenyanthropus platypus making tools in Kenya. We've got these mystery cut marks in Ethiopia. And who knows what else is waiting to be discovered. It's starting to feel like our family tree is less like a straight line and more like a bush,
Yeah.
with branches going off in all kinds of directions.
Yeah, I like that analogy. And the more we learn about our ancestors, the more complicated and interesting that bush becomes.
I know Professor Spoor mentioned a couple other, characters in this prehistoric story, Australopithecus, Diarymida, and the birch foot. Can you tell us a little more about those and how they fit into everything?
Sure. So, Australopithecus diarymida was another hominin species that lived in Ethiopia around the same time as Kenyanthropus platypus, and they had some similar features, which makes you wonder, what was their relationship? Could they have been making tools too?
So we could have had multiple hominin species living in different parts of Africa, all potentially developing the ability to make tools, on their own.
Yeah.
That really changes how we think about human evolution. It's not just a single line. It's more like, well, like we said, like a bush.
It really does. And then we have the Bertelli foot. That's a partial foot. It's 3.4 million years old. They found it in Ethiopia. And here's the interesting thing. This foot had an opposable big toe, kind of like, what you see in apes today.
Hold on. What's so special about an opposable big toe? Does that mean they were like swinging from trees instead of walking?
Not necessarily. I mean, an opposable big toe usually means an animal is good at climbing trees, but it doesn't mean they couldn't walk on two legs, too.
Hmm.
What's important is that it shows us a different lineage of hominins, a different branch on that bush, separate from the one that led to us.
So there could have been all these different groups of early humans with different, physical traits, all living in the same place, maybe interacting with each other. It's like a reality show, but millions of years ago.
It really gives you a glimpse into just how diverse our ancestors were. And And remember, this is just the beginning. And the more we explore, the more we realize just how much we don't know about our evolutionary past.
It's like every time we find an answer, we just end up with more questions. But that's a good thing, right? That's what keeps things exciting. So where do we go from here? What are the big questions that researchers are trying to answer now?
Yeah, it sounds like we're really just starting to understand how complex early human evolution really was. Every new discovery seems to kind of open up new possibilities and makes us question what we thought we knew.
Well, that's what's so great about science. It's a never-ending search for knowledge. We're always refining our understanding of the world and our place in it. And when it comes to, human evolution, there are still so many pieces of the puzzle missing.
It's almost like we're like time travelers trying to put the past back together from
Wow.
these like little clues, a broken stone here, a fossil there. But even those tiny fragments can tell us amazing stories. Absolutely. Every discovery, no matter how small, can change how we view the past. And the more we learn about our early ancestors, the more we realize that they weren't that different from us. They were innovative, they were adaptable. They wanted to understand and shape their world.
It makes you wonder if they were capable of all that over 3 million years ago.
Yeah.
What does that say about us? If they could overcome challenges and adapt with so little, what could we achieve with all the knowledge and technology we have now?
That's a really, really powerful thought. It reminds us that, we all share that same creativity and resilience that helped our ancestors survive. We might face different problems today, but that basic human drive to explore, to innovate, to push the limits, that's still there.
Yeah, it's inspiring when you think about it that way. It connects us to this long history of human ingenuity. We're part of something much bigger than ourselves.
Exactly. And that's why studying human evolution is so important. It's not just about digging up old bones and tools. It's about, understanding where we came from, how we got here, the journey that connects us to everyone who came before us, and the potential that we all have.
So as we wrap up this deep dive into the world of early tool makers, what's the one thing you want our listeners to think about? The big question that will stick with them.
Well, if our ancestors could make tools, adapt to new environments, and share their knowledge over 3 million years ago, what does that say about the potential that we all have inside us today? What amazing things could we accomplish if we could tap into that same spirit of innovation and collaboration? I think that's something worth thinking about.
That is a fantastic question. And on that note, I want to thank you all, our listeners, for coming with us on this journey back in time. We hope you've enjoyed learning about our earliest tool makers, and we hope you'll join us again for more deep dives into the world of science and history. Until next time, stay curious and keep your minds open. You never know what incredible discoveries are waiting to be made.